Hello and welcome to part 4 of our complete road design tutorial using Civil 3D 2025. In this video, we are going to design our road corridor with an intersection at where the alignments meet. A corridor in Civil 3D is a dynamic 3D model that represents your roadway design. It combines horizontal and vertical alignments, profiles and assemblies to define the road structure. For this tutorial, we'll model two intersecting roads, one with a depressed median and another with a basic crown, with precise curb return alignments. Kindly watch the previous videos to learn the steps discussed from creating points, surfaces, alignments, profiles and assemblies creation for this road design. In case you are watching this channel for the first time, kindly take a second or two. Hit the subscribe button so that YouTube notifies you when I upload the next video. And to the subscribers, I want to thank you all for the continued support, because without that support, this channel cannot be where it is. And with that said, let's get started. We have alignments, assemblies and design profiles for our two road sections defined, and we can proceed to create our corridor. Go to Corridor drop-down and select Create Corridor. Name your road appropriately from the name field here. After this, select your alignment from the available list. Select Road 1 alignment and set the corresponding profile. Select Road 1 full assembly we defined previously. You can set your corridor style and code set style from this dialog here. Set the target surface to the existing ground surface. I will then proceed to select the same assembly at the feature lines dialog. Enable set baseline and region parameters, then press OK. Hit apply, then select rebuild the corridor. The corridor has been modeled and it appears on the screen as a 3D representation. We can edit the intersection assembly at the left side by removing the shoulder and daylights. This is Road 1 left offset, and at this intersection region, we can edit the assembly to have the left lane, then add Road 2 to join to Road 1 with the defined curb returns. We'll use Road 1 left offset as a target for the lane width. The offset value represents the distance of edge of travel lane to the assembly baseline or crown. You can watch the previous video in the channel to learn how we created these assemblies with parameters. I will highlight from the shoulder, then hit delete. This will help us to avoid an overlap with the adjoining Road 2 which intersects at the left side. With the main corridor created, you can select it, then go to Corridor Properties. From here, you can select Set All Targets, then go to Surface tab. Set all to existing surface. Press Apply, then OK. Select Rebuild Corridor from here. The corridor has been matched to the existing surface and you can see the daylight conditions at the ends. We can break the corridor into regions that define where a specific assembly will be applied. To create the intersection region, select the corridor, then select Split Region command. Click once along the corridor, then click again to specify the split location. I will add another split at the lower side with the command still activated. Set the region edge to match the curb return endpoint. I will add a gap between the region to view the curb return alignment endpoint. Select on this grip, then drag this way to separate the regions. We need to see the endpoint of the left curb return at this upper side of the intersection region. Place the cursor above the curb return or select it to locate the endpoint. I will select the intersection region, then use the grip and move it so that the curb return endpoint can be visible. Select the corridor, then use the region grip to snap it to the endpoint of your curb return here. Select this other region grip, then align it to the corridor. Repeat the same at the lower side of the intersection. Align this region to the curb return endpoint. Then move this other grip to the intersection region. Splitting regions ensures that different assemblies can be applied. Once we have the corridor region split, drop at Modify Region, then select Region Properties. Select the intersection region by clicking. Select the assembly to be used at this region from here. Drop, then select Road 1 intersection assembly. The left shoulder and daylights have updated at the intersection. Remember to set the surface target to the existing surface once you add assembly components at the corridor. Set all surface targets to the existing surface. Then press OK and rebuild the corridor. We have defined the intersection region to utilize the intersection assembly, which only has the lane at the left side. You can use different assemblies in the corridor regions that have a baseline. This intersection assembly has been utilized at the intersection region, which has its endpoint at the curb return. With the main corridor created, we can add Road 2 alignment as a baseline for the intersection road to design Road 2 corridor. Select the main corridor, then add baseline. I will select Road 2 alignment from the list, and Civil 3D sets the associated profile. Select Road 2 full assembly, then hit OK. Rebuild the corridor to update the model. We have added Road 2 to the main corridor using Add Baseline command. The two roads are highlighted as one corridor when selected. I will move Road 2 region back to view the curb return endpoint. Drag this region boundary to intersect with the curb return endpoint. Select the corridor, then go to Corridor Properties. Click Set All Targets. Then set all surface targets to the existing ground surface and hit OK. Apply, then rebuild the corridor. Surface targets in Civil 3D tell the corridor where to tie into the existing ground, ensuring that the design blends seamlessly with the terrain. Targets ensure that the secondary road aligns with the main corridor at both the horizontal and vertical levels. Road 2 profile controls the elevation of our corridor, which follows Road 2 alignment. The assembly used at the intersection terminates at the left offset, which also aligns with the curb return alignment. We can add the curb return alignments as baselines to the main corridor. Select the corridor, then select Add Baseline command. Select the left curb return from the alignment list. Then profile and pick the left curb return assembly. We can also add the right curb alignment and profile. Then select the right curb assembly to match the intersection design. I will add both assemblies at the feature lines for critical components that represents key design elements. Then press OK. Select the corridor, then rebuild the corridor from here. We have started the manual intersection creation and we can go to the tool space palette, expand corridor, then select our corridor, right click, then select rebuild automatic. Our corridor will now rebuild automatically as we define our intersection targets. For the next step, select on the corridor, then select corridor properties. I will select on the right curb baseline, which highlights when selected. Then go to frequency. I will reduce the horizontal baseline value to 2 along tangents and curve increment, then press OK. We can repeat the same at the left curb baseline. Frequency refers to the spacing of corridor section views along the baseline. Press OK to proceed. Higher frequency improve accuracy but increase file size and processing time. You can select on the assembly or select the baseline to edit the frequency. I will click here, then set row 2 frequency value to 10 along tangents and 5 at curve increment and press OK. With road 1 as our main corridor with 3 regions, you can select on the corridor baseline, then click on frequency column. I will set 10 along tangents and 5 at curve increment, then press OK. Press apply to apply the new frequency settings to the corridor. The section views lines have increased along the tangents and curves as defined with our frequency value. I will select at the corridor and notice that we don't have daylights at the curb returns. We need to set the existing surface as the surface for all surface targets from here, then hit OK. Press apply to rebuild the corridor. We can now discuss how to set targets for our intersection by manually defining our width and elevation targets using offset and curb return alignments. This is the left curb return we defined in the previous video. Row 2 alignment is located at this lane edge in this assembly. I will zoom to the intersection area, and we see that the curb return assembly should be targeted to road 2 alignment and to road 1 left offset, which can be used to target the lane. We'll discuss how to set targets at each side of our intersection curb return baselines separately for a comprehensive understanding on target mapping. I will select the corridor, then go to corridor properties. We can start with the right curb at this side of the intersection. Click in the target column, then switch to offset and elevation. Drop here, then have the lane only selected from the sub-assemblies. Select the lane only to accurately set the correct targets. Click outside to update the list. The width target controls the lateral extent of the corridor components like lengths. Select road 2 alignment from here, then check the box beside it. We also need to target the lane width to road 1 left offset. This offset will act as a boundary that will target the width of the lane used in the curb return assembly. Check the box beside to include it as a width target. Select outside elevation, then select the associated profile for the alignment. Find and select the other profile, which for this design is the road 1 left profile. Check the box, then press OK. Hit apply to update the corridor. Width targets ensure your corridor dynamically adapts to varying widths. The selected width targets extends the lane within the inner region of the selected alignments. We can do the same at the left curb. Select the corridor, then go to Corridor Properties. Select the left curb assembly, then click at the target column. In the Offset and Elevation tab, you can drop here, then only have the length selected from the sub-assemblies. We can have a look at the left curb before assigning the targets. I will use this left offset and row 2 centerline alignment as the lane width targets. This is the importance of accurately naming your alignments and profiles as discussed in part 2 of this complete road series. Select outside elevation, then select road 2 profile and road 1 left profile to match the selected alignments for the width targets. Then press OK. Hit apply to update the corridor. And that's how you can add curb return alignments as baselines in a corridor in Civil 3D. This step is essential for accurate intersection design, ensuring smooth transitions and a polished final model. You can set the visual style to realistic to view the 3D model. We have a hole at the intersection which we'll fix in a moment. I will revert to 2D wireframe, then show you how to remove the hole. Select the corridor, then select Add a Section. Hover over the left curb, then click. Zoom at the intersection, then click to add manual sections along the curb region boundary as seen. Then press Enter. Select Add a Section, then select the right curb baseline. I will add points along this centerline and offset alignments, then hit Enter. I will need to add a section and snap it at the intersecting point of the alignment and profile. Zoom at the point, then click where the two lines meet and hit Enter. I will repeat the same at the left curb baseline. Adding a section allows Civil 3D to calculate a smooth transition within the gap area, effectively filling the hole in the corridor. Finally, review your intersection in 3D to ensure the holes are filled and the transitions are smooth, and if needed, make further adjustments to the section or targets. This ensures your design isn't just visually appealing but ready for real-world implementation. We can proceed to create a corridor surface that forms the foundation for calculations. Go to Corridor Properties, then switch to Surface tab. Click Create Surface to add a new corridor surface. Next, define the data used and specify a code, then Add. I will add as breakline, then go to Boundaries. Right-click, then select Corridor Extends as outer boundary and hit Apply to update your corridor. Boundaries keep your surface clean and focused, avoiding unnecessary triangulation outside the designed area. I will go to Geolocation tab, then turn on the S3 imagery to view the corridor with the map data. Maps bring real-world context to your Civil 3D designs and are perfect for understanding terrain, surroundings, and connectivity. We have completed to design the corridor with an intersection defined from curb return assembly targets. Kindly watch the previous videos in this complete road series for a step-by-step guide on this road design with design check sets for alignments and profiles. Feel free to ask questions concerning any topic discussed in this road design if you need clarity on any design aspect. We created detailed assemblies for this design in the previous video for our corridor design, and you can watch it from the channel in case you are joining us in this design. Kindly give this video a thumbs up if you found this tutorial helpful. Subscribe and turn on the notification so that YouTube notifies you when I upload other videos. In the next video, we'll explore creating cross-sections, calculating earthworks and generating plots. By the end of this complete road series, you'll have a full understanding on road design workflows. That's it for this video. Thanks for watching. See you in the next.